Euclid's 47th proposition says, given a right angled triangle, the square of the side opposite to the right angle is equal to the sum of the squares on the remaining two sides. Or we can say BC square is equal to AB square plus AC square. And I'm sure you remember this. This is called the Pythagoras theorem. Okay, let's see how we can prove this. We are given that this is a right angle triangle and angle A is 90 degree. Okay, now for that what we are going to do is we are going to construct an actual square on top of BC. Similarly, a square on top of or below AC and on the side of BA. Let's connect F and C, and similarly let's connect D and A. What we will also do is create a perpendicular to line DE from the point A, and we will mark the points of intersection T and L. So what do we have here now? What can we figure out from this? This triangle FBC is congruent to DBA. How can we say that? Because if you notice, this angle FBA is right angle, DBC is right angle. That means they are equal to each other. What we'll do is FBA, to that we will add ABC. Again, angle DBC, we will add ABC. So we get DBA. We are adding the same angle to equal angles. So that means equality will be maintained. So which means angle FBC is equal to DBA. So this angle is equal to this angle. FB is equal to BA because it's a square, and these two belong to two different triangles. Similarly, this side BD is equal to BC. They belong to different triangles. So which means we have this side equal to this side equal to this side, and this angle. So side angle side. So based on that proposition, we can say that these two triangles are congruent. Now what else can we infer from this? We have figured out that these two triangles are congruent. Now if you notice, this is a parallelogram, right? DBTL is a parallelogram, and this is a triangle which has the same base as the parallelogram and is between the same parallel lines, right? Which means area of the parallelogram is twice the area of this triangle. Okay. Similarly, if we look here, what do we notice? This triangle and this square, which is also a parallelogram, remember? They both have the same base FB and they are between the same parallel lines. Area of the square would be twice the area of this triangle. So keep this in mind. Twice the area for this parallelogram and for this square, which means since these two triangles are congruent, we can say that this square is equal to this parallelogram. Okay. Now, just like this, what we'll do is look at another part of this part of the figure, this square. We looked at this square and we have come to the conclusion that this area of this rectangle is equal to the area of this square. Okay. Now let's look at this. Let's connect AE and BK. We end up with two triangles. Just like we did for this part also follows the same logic. This is 90 degree, this is 90 degree. Purely based on the construction, we can say that. We are going to add BCA, angle BCA to both the 90 degrees, both the angles. So what do we get? We are adding the same thing to equal angles, so which means the equality is maintained. Which means angle ECA is equal to angle BCK. So this angle is equal to this angle. This side is equal to this side. This side is equal to this side. So side angle side. Based on that proposition, we can say these two triangles are congruent. Now, again, look at this triangle and look at this parallelogram. They are both between the same parallel lines and they have a common base, which means the area of this parallelogram is twice the area of this triangle. Similarly, here if you look at it, CK is parallel to BQ, and this triangle and this parallelogram AQKC, which is a square in our case, they both are between the same parallel lines and have a common base. That means the area of this square is twice the area of this triangle. Similarly here, CE is parallel to LA or AL. This triangle and this parallelogram TCEL, they are between the same parallel lines and they have a common base. That means the area of this rectangle is twice the area of this triangle. Area of this square is twice the area of this triangle. These triangles are equal to each other. That means this rectangle is equal to this square. Now, this was equal to this square. This was equal to this square. If we add up these two parallelograms, what do we get? This square, DBCE. So we can say the square of AB or square on AB is plus square on AC is equal to square on BC. So that is proposition 47. As usual, let me remind you, there is a link to a PDF book which describes all the 48 propositions of Euclid's book 1 of elements. That's it for now. Bye.